Hello, pre-algebra students, and happy flood day. I hope that you're safe and sound at home today. And you won't be watching this today unless you are like right on top of YouTube and you decide to get a jump on things. But anyway, we're going to look at fraction operations review today. So that means everything except division. And I know some of you learned division as well, but from our pre-assessment, I noticed that we definitely could use a refresher. So let's start with adding and subtracting, and then we'll move on to multiplication. Okay, so to add or subtract fractions, you must have a common denominator. When you have mixed numbers, you have a couple of options there. You can leave the mixed numbers when it's convenient and use maybe regrouping if you're doing subtraction, or you can change them to improper fractions. Which I prefer some of the time, and then of course some of the time I don't. So this is going to depend on the problem there. Okay, so this part is a little bit new. When a fraction is negative, only its numerator is negative. And I want you to try to think of the denominator of the fraction as kind of more like a unit of measurement. So let's think about, for example, if I said negative 2/3, that's negative 2 units of 1/3. So that would be like if I had a pie, and it was split into thirds. Whoa, that's not even remotely thirds, Miss Lecomte. Let's try that again. Let's just do the whole thing again. So if I have a pie, preferably, I don't know, meringue. No, maybe not. Apple? Yeah, apple's better. There we go. That's more like thirds. So negative 2/3 would be I ate 2/3 of it. So it's 2/3 are gone. Okay, that's how I want you to think about a negative fraction. It's not two separate numbers, it's one number altogether, so it's negative 2 units of 1/3. That's how I want you to think of a fraction that's negative. Okay, let's do some problems. So remember to pay attention to what you have, and if you've got a problem with some integer action going on, we'll see that in a few minutes, do think about that along the way. Okay, so we need a common denominator. For 3/5 plus 1/3, so we have 5 and 3. Well, 5 and 3 are what we call relatively prime. They're individually prime numbers, but they're also relatively prime, so their only common factor is 1. So that means that I can swap denominators to multiply. Because multiplying by 3 over 3 or multiplying by 5 over 5 is the same thing as multiplying by 1. And that's why I'm allowed to do that. And then, once I do the multiplication and rename the fractions, and they have their common denominator, now I can add those numerators together, and I've got 14 fifteenths, excuse me. And there you go. All right. Same idea, common denominator. Now, to find a common denominator from scratch, so you have a problem, you have to find a common denominator, take the two denominators, take the bigger one. Ask yourself, does this other number go into 8? Why, yes, it does. That means you already have your common denominator. So 3/8 does not need to be renamed. But for this one, we're going to multiply so that the denominator is an 8. And we're going to get 6/8. So we have 3 minus 6/8. And 3 minus 6 is negative 3. So you're going to put your negative sign out front. Oof, sorry, I was struggling to write there for a second. Let's fix that. Put your negative sign out front, because 3 minus 6 is negative 3, and it's negative 3/8. Okay? Last one. So this time, we have sixths and fourths. So again, I'm going to take the larger number. Does 4 go into 6? No, it does not. Now think about the next multiple of 6, and that would be 12. 12 is my common denominator here. Notice the first fraction is negative. For the purposes of adding them, I'm going to go ahead and put that negative sign on the numerator, like we talked about, so it's either out front or on top. And what are we multiplying by? Well, let's see. 6 times 2 is 12, so 1 times 2 is 2. So negative 1/6 is negative 2/12. 4 times 3 is 12, and 3 times 3 is 9, so 3/4 is 9/12. So this is now negative 2 plus 9 all over 12. And negative 2 plus 9 is 7. And so that one comes out to be 7/12. Okay, let's do 3 more. This time we're going to look at some that involve some mixed numbers. Now, if you think you've got this down and you don't want to sit through watching me write it out, then pause it, do them yourself, and then fast forward to the answers. And if you get them all right, then you can move on more quickly. And if you don't want to do that, then sit back, relax, enjoy my mathing. But do make sure you're taking notes. Okay, so for this one, we've got 6 and 8. 8 is the larger. 6 does not go into 8, so 16, no. 24, yes. So I have 5 and so many 24ths, plus 2 and so many 24ths. Okay, so what did I multiply 6 by to get 24? Well, that would be 4. Okay, so 20 24ths. So 5 sixths is 20 24ths. And over here, multiplying the 8 by 3, so 9 24ths. And when I add them together, I'm going to have a half improper, half mixed number answer. And clearly that's not going to work. So one whole thing, or 24 24ths, so this is 7 plus 24 24ths plus 5 24ths. So that's 7 plus 1, so that's 8 and 5 24ths. If you got that right on your own, that's awesome. And you can keep going to the next one. All right, so the next one. So again, we need a common denominator. So I'm going to take a look at this. I'm going to say, well, let's see. We have tenths and fourths, so 4 does not go into 10. Next multiple of 10 is 20. 4 does go into 20. And there you have your common denominator. So remember, move that negative sign to the top. Okay, now go back. What am I doing to 10 to get 20? I'm multiplying by 2, so that's 6, negative 6 20ths. And over here, I'm multiplying by 5, so that's 15 20ths. And this is a keep, switch, switch situation. So I'm going to keep the whole first fraction, so it's keep, and then switch, switch. So I have a negative plus a negative. Oh, that's much easier than what I thought I was dealing with a minute ago. Now I'm just adding 6 20ths and 5 and 15 20ths. It's just that they're both negative, so my answer is negative. And I get negative 5 and 21 20ths, which, as we saw a moment ago, we're going to consider, and I want you to think of this, remember, this is one number together. Try not to get confused by the fraction there. So this is 5 20 20ths and 1 20th. So that's 6 and 1 20th, so it's negative 6 and 1 20th. Now, if the way I went through that was confusing, jot a note in your notes, jot down a note in your margin of your notes to go over that with me in class, okay? And then remember to ask, because, you know, I can't read your mind and stuff. Wouldn't that be awful if I could totally read your mind? You wouldn't want that at all. Okay. Common denominator once more. We already did this one. 5 and 3, we know that. That's 15. So this is 9 and 9 15ths minus 7 and 10 15ths. Oh, no. Oh, this is one of those. I don't have enough fraction to subtract. So if I'm going to use improper fractions, that means I'm going to be using some kind of significantly sized numbers here. So I need 9 times 15. So 9 times 15 comes out to be 135 plus 9, because I've got to do... so let's see, 135 plus 9 be 144 over 15. Minus 7 times 15 would be 70, and 35 would be 105 plus 10, so 115 over 15. And we've kind of reached that point where having a calculator is definitely helps avoid the careless errors. And so it's possible that I may time and again use a calculator to help myself with that. So 144 minus 115, that's 29 15ths. And so that's 1 shy of 2. Look at that. So 30 15ths would be equal to 2. So we have 1 and 14 15ths. Oof. Okay, fractions are exhausting. Let's move on to multiplication before this video gets too long. Okay, to multiply fractions, first rewrite any mixed numbers as improper fractions. Yes, you have to do that. That's not optional like with the addition and subtraction. Multiply numerators, multiply denominators. Remember the rules for signed numbers. They still apply as they did before. And remember to simplify. Now this is the part that really will help. Now on this particular problem, 1/6 times 2/3, if I multiply straight across, I don't get something that's that difficult to simplify. I get 2/18, which is 1/9, which is that's not hard, okay? But let's look at the next one. So, why are we simplifying before we multiply? Because it makes the numbers smaller and more manageable. Makes the numbers smaller and more manageable. So, I don't want to do 88 times 25. That's crazy talk. So instead I'm going to say, ooh, look, 88 and 99 are both divisible by 11. That gives me an 8 and 9. Oh, look, 75 and 25, I can divide both of those by 25. That gives me a 1 and a 3. And now when I multiply across the top and across the bottom, I get 8/27ths, and that is much nicer than dealing with whatever 88 times 25 and 75 times 99 would have been. They're smaller numbers, okay? I was able to make it an easier problem by thinking ahead to simplify. And that is why we simplify before we multiply. Now, why are we allowed to do that? Now, because the commutative property says I could actually switch these denominators right here and make it 88 over 99 and 25 over 75, and it's no different. And that's why we're allowed to simplify. So let's try some. Okay, you only have 3 more problems to go in this video because for the multiplication, there's just not as much to practice. So let's take a look here. We've got 1/2 times -6/7. Well, the first thing I notice is that it's a positive times a negative, so I know my answer is going to come out negative. Okay, so I definitely know my answer is coming out negative. Okay, I do not want a common denominator that makes the numbers bigger. What I want to do instead is simplify, finding a common factor of 2 here, so divide that by 2 and divide that by 2. I know my answer is negative. Multiply across the top, 1 times 3 is 3. Multiply across the bottom, 1 times 7 is 7, -3/7. Done. Easy, right? Next one we have is a negative times a negative. So we know that a negative times a negative is going to come out to a positive answer, so do make sure you think about that in this problem. So I'm seeing that I could divide both of these by 6 right here, so a 2 and a 1. And I could divide both of these by 5, so a 4 and a 1. Negative times negative is a positive. 1 times 1 is 1. 2 times 4 is 8. 1/8. And that's finished. Last problem of the video. Okay, so now we have a couple mixed numbers to multiply. We have to change them into improper fractions. Unfortunately, not optional at all. So we have to multiply here. So we are going to multiply and then add. So multiply, come on now. I'm having trouble getting my color to go to the correct color. Okay, we'll just stick with the blue. Multiply, add. Sorry for the delay. So 6 plus 1, 7. So 7/3 for 2 and 1/3, which makes sense because 2 whole things would be 6/3. 6 over 3. That's supposed to be a 3 there, sorry. 6/3. Okay, do the same thing here. Multiply, add. So we get 14 plus 5 is 19. So 19/7. We have a positive times positive, so I don't need to worry about my sign rules for my rules for signed numbers here. Okay, so now we have a chance to simplify. So I could say divide both of these by 7, leaving a 1 and a 1. So 19/3 is my answer. And you're going to go ahead and switch that right back to a mixed number. So 3 goes into 19 6 times, with 1 left over, 6 and 1/3, because 19/3 is 18/3 and 1/3. And the 18/3 is 6, and then you got your 1/3. And that is all the fraction review you have for today. So we'll do division in class coming up very soon. See you guys in class.